Today, I'd like to talk about how we can use alarms, correlation rules, and cyber threat feeds in the ESM in creative ways. I will show you how to ingest indicators of compromise in an automated and quick manner, alert on an important or suspicious activity without overloading your analysts, and pivot off of these simple alerts to create more complex rules and alerts more catered towards your environment, all while using the built-in features found in the McAfee ESM. For this example, we will need to have an ESM, combo ESM, or an ESM with an attached ERC, and either a correlation engine or an attached ACE. In this example, I will only be using a correlation engine built into my ERC. Let's get started. We first need to discuss how we're going to get indicators of compromise into our SIM. We have a few options that I will lay out that allow us to automatically pull useful information into the ESM without a need for scripts or API calls, etc. The first option is watch lists. There are two types of watch lists, dynamic and static. Think of watch list as a SIM version of a notepad. It's just a container for a specific field filled with values that we want to keep and use in the future. Often watch lists will contain either IP address lists or usernames, but they can also utilize a number of other values that we might need in the future. Here I've created a watch list called sans bad IPs, and I have configured it to update every 15 minutes with the values found on the web page. On the sources tab, I have set the watch list type as HTTP HTTPS and placed the appropriate URL in the URL field. In this example, I do not need to use authentication, so I have set that to none, and I've also selected the method of GET and left the Ignore Invalid Certificates checkbox checked. On the Parsing tab, I'm able to view how the ESM is interpreting the website. We have the option Header Lines to Skip, which allows us to eliminate unneeded lines from our watch list before the regular expression is used. An option for a New Line Delimiter, which is useful when the web page does not present information in a list format, unlike what is seen here. An Ignore Expression box to eliminate unwanted values, and the regular expression, which is used to select the values we want to ingest. Once we have a valid regular expression, we should see at least one matching group. This is used to select the correct capture group to ingest from a regular expression. As we can see here, I have two capture groups in my expression, but group 1 is the only capture group that has the values I'm looking for, so I will select group 1 in this example. In the Values tab, I must select the type of field used in the watch list. This dictates what field I can use the watch list for. In this case, I have selected IP address, which allows me to use the watch list in either the source or destination IP address fields. Unfortunately, not all fields have a unified field, source user and destination user being the best example. In situations such as those, you will have to recreate the same watch list for each specific field you need. Dynamic watch lists allow us to pull a single value type from various sources such as websites, file shares, and databases. The next option we have is using cyber threat feeds. This is a great way to ingest multiple indicators and place them into watch lists along with looking to see if these indicators have already been seen in the SIM up to 60 days ago. However, depending on the indicator being ingested, there can be a lot of noise created by this feature as there's not a great way to limit its scope. I recommend only using backtrace if you're not ingesting IP addresses, as your external firewall events will likely trigger a lot of false positive alarms. There are three locations I would look to for cyber threat feeds. The National Cyber Awareness System creates alerts that can contain STIX files containing threat indicators identified by the US government that can be manually ingested into the SIM. HaloTaxi is a free service offering several feeds that you may find useful. And finally, there's the ISAC system. ISACs often provide a taxi feed subscription option that will provide IOCs that are being seen by other companies in the same business sector. If you are not already a member, I strongly recommend you check out the ISAC for your sector, as it will provide very useful information more specific to your organization than a simple list of IOCs found on a website. In my example, I provided the HaloTaxi URL and provided the collection name to pull only indicators associated with abuse.ch. Next, we will set the frequency of the taxi pull. In this example, I have chosen daily at midnight. The watch list tab allows us to select the indicators ingested and the watch list we wish to store the values. Here we have a list of possible STIX fields to use in any possible watch list for that field. As you can tell, there is some overlap. Several fields can select different watch lists, so some trial and error is required to identify the fields and their best corresponding watch lists. Finally, the backtrace option allows us to look up to 60 days for the cyber threat indicators we have ingested. It will create alarms for any indicators found, all without the need for an historical ACE. You will likely want to be careful when using the backtrace with any IP indicators, as they have a tendency to create a lot of false positives with the external firewall deny events that cause the backtrace to fire an alarm. I recommend only using backtrace with higher value IOCs such as file hashes and file names to limit the noise. In this example, we're going to set how far back we want to look in the ESMDB, select where to assign the alarms, and select what type of data to look at. We're also going to choose the action of any alarms that might fire when an IOC is detected. The options listed are the same as what is found in the alarm section of the ESM. Now that we've ingested our IOCs, we may want to create some alerts to let us know if they are seen by the ESM going forward. Alerts are a great way to inform us of activity that we care about, and in this case, we're going to create a simple alarm to let us know if anyone's talking to an IP found by the abuse.ch feed from HaloTaxi. There are two main types of alarms you will most often see in the ESM, field match and internal event match. In this example, we'll be using the field match alarm. Field match alarms offer the ability to offload the query directly to a receiver, ACE, or ADM, thereby freeing up the query load on the ESM. Field match alarms not only provide an improvement in system resources, but can allow for faster alerting, as field match alarms do not have to wait for the event to be posted to the data bus and will trigger immediately when the criteria has been met. I'm going to create this alarm, naming it abuse.ch, and provide it an assignee and a criticality level. It is always better to assign an alarm to a group rather than a specific user. That way, the alarm can be seen and acknowledged by members of the group versus just a specific user assigned to the alarm. Here we can see an example of the field match Boolean logic. Down here, we can see we have a maximum condition trigger frequency of 10 minutes. Maximum trigger frequency allows us to limit how often the alarm will fire. Once this Boolean expression is met, the SIM will not look for this condition again within a 10-minute period. This can create some blind spots in the ESM, however. Field match alarms allow us to set this to 0. However, we want to be very careful when doing so because we can overload the SIM and back up the queue for the alarms. The Devices tab allow us to push this to specific devices. In this case, I'm sending it to both my ADM and the ERC. However, if I was using something like a correlation rule in my condition, I may actually only want to limit it to either my ACE or my correlation engine. This would optimize the amount of work being done by the device and only limit its scope to that particular device that I care about. Next, we have our actions and escalation tabs. These provide the actual functions of what the alarm is going to do when the event is seen. We have the option to log the event, which creates an additional event in the local ESM section of the SIM, create a visual alert, which creates a pop-up, create a case, which opens a case in the case management system in the ESM, update a watch list or several watch lists, send a message, generate reports, execute remote commands, such as maybe shunning something in a firewall or a router, send it to remedy, assign tag with EPO, blacklist in NSM, and create a custom alarm summary. Finally, we have the escalation tab. This tab is much like the actions tab, however, it's a little bit more limited, and it's used for when the alarm has not been acknowledged after a certain period of time. This allows you to be able to assign it to a new group, send a new message, or create an additional visual alert, generate a report, or execute a remote command. It's often left blank. However, there are some decent scenarios where we might want to use it. Another way we can use our watch list is in a correlation rule. Correlation rules allow us to use more advanced Boolean logic to help eliminate unwanted noise and focus on a specific set of criteria we wish to monitor. In this example, I've created a correlation rule to monitor communication with the IPs found in the SANS bad IP watch list we created earlier. I will not go into how best to create a correlation rule in this video. However, the logic of this rule is designed to monitor successful inbound traffic from SANS bad IPs, or any flow with a SANS bad IP, or any outbound communication attempts to a SANS bad IP, regardless of whether it's successful or not. It also has logic to ignore successful inbound SANS bad IP traffic destined to my DMZ web servers on the normal web server ports. This rule logic will still alert on SANS bad IP communication to a non-web server or to a web server on a non-web port. All of these expressions help limit the rule to traffic I can control and helps me eliminate unneeded events. Once I've created this rule, I can then create a field match or internal event match alarm using the correlation signature ID if I want to be notified when the event occurs. Finally, I want to demonstrate how we can use these techniques to eliminate unwanted alarms from the ESM while still tracking important activity. In this example, the alarm is set to look for a correlation signature ID. The correlation rule tends to fire multiple times for a single destination address, and I would like to limit it to only firing on new destination addresses that have not already triggered the alarm within a 24-hour period. I've configured the watch list called exposed IPs to track each destination IP for 24 hours. The logic displayed here is set only to fire when the event has a destination IP that is not already in the exposed IPs watch list. If a new destination IP is detected, the alarm fires and appends that new destination IP of the event to the exposed IPs watch list. Once the watch list has been updated, the appropriate device will receive the new values within about a 10-minute window, thereby stopping any new alarms from firing on the same IP. Due to the latency of the watch list values being updated on the device, the alarm may continue to fire within the first 10 minutes if the condition is still met. However, if we set the maximum trigger frequency to 10 minutes, we should limit this from happening. Remember that a 10-minute maximum trigger frequency creates a gap in the alarm for 10 minutes. As a result, you may want to experiment with the alarm settings to find out what is best for your use case. The examples I provided were just some of the many ways we can use the SIM to identify important events in our environment. If you found this video useful, please feel free to comment below. You can find out more about UNS by visiting our website, or you can follow us on Twitter or LinkedIn.